Welcome to Azure Labs. This is the first lab in a series which I hope to grow to 25, 50, maybe even 100 labs. Who knows? My plan is to create 2 labs a week. The labs will follow the structure of a short PowerPoint slide show, if needed, to cover any theory, and then a 15 to 25-minute lab. After each section of labs, I hope to have a 10-question test to test your knowledge. Of course, the labs will vary in difficulty, and today's I would rate as easy. This is the first time I've ever created anything for YouTube. I'm hoping to share my passion for Azure with you, the YouTube crowd, and hopefully we can all learn together and have some fun together and explore the wonderful world of Azure. The first set of labs will follow the material covered in the Azure 103 course. As you can see, the first lab, we will be creating a VM. This is really lab 1A. This lab will cover installing a VM via the portal. Next, we'll create a VM via the PowerShell, which would be lab 1B, and then using Azure command line, which would be lab 1C. Before we begin the lab, let's cover a few slides just to cover some basics of creating a VM. This slide here shows us what resources are needed to create a VM in Azure. First thing you need to have is a VNet or a network. Here I'm using 2 class full addresses, 172.16/16, and then you need a subnet to put the VM in. So that'd be 172.16.1.0. Also, you need a resource group. A resource group is where you place your resources which have a common lifespan. So, for example, if I was going to create a web farm, I'll put all those VMs in the same resource group because they'd all either live together or die together. You need to give it a name. And then you need to create a storage group. But only you need a storage group if you're not going to use managed disks for the VM. And just about every resource, and I agree, you should use managed disks. So we will not need a storage group. Naming conventions. Are there any rules when I create the VM? You bet. You could create Linux VMs and Windows VMs. We will be concentrating all on Windows VMs. Way down the line, maybe lab number 33, we'll do a Linux. But 1 to 15 length, that's probably because of the old NetBIOS length from back in the olden days. It is not case sensitive. Here's the characters you can use. You could have a dash. And they suggest a naming pattern such as the name of the VM, what role it's going to serve, and then a number. So here they come up with the name would be ProFX for the name of the VM, SQL for the role, and then it's VM number 1. I'm not in love with that example, but you should come up with some kind of naming structure for your whole organization. That's a good idea. I'm just not sure if that's a great one. When you create the VM, you have to create its size. Think of this when you used to buy a computer. You'd have to create a CPU, memory, how many CPUs, what kind of CPU, how much memory. And Azure breaks it down to different types, different sizes, and gives you a description. So general purpose would be these sizes here. They provide a good balance CPU to memory. If you're doing something heavily graphical, you want GPU, specialized virtual machines, targeted for heavy graphic rendering. So, pretty good chart there. Next, here are just some general tips on VMs in general. Configure multiple virtual machines in an availability set for redundancy. It's a good idea. There's our good friend, managed disks. Use managed disks for VMs in an availability set. I agree with that. I would take it one step further and say always use managed disks whenever you create a VM. Use scheduled events to proactively response to VM impacting events. It's a good idea. Anytime you can automate anything and be proactive about it, you're gonna feel good about what you do at your job, and I'm sure eventually be financially rewarded as well. Configure each application tier into separate availability sets. That's really the definition of availability sets. Combine a load balancer with availability sets. Excellent idea. And use availability zones, protect from data center level failures. A lot of new terms here, and the biggest term that we learned, we had a review of managed disks from 2 slides ago, which is good, and availability sets. Let's talk about those briefly. Availability sets are made up of fault domains and update domains. Let's just read over here, and then we'll talk about the picture. Fault domains define the group of virtual machines that share a common power source and network switch. Makes sense. What's a fault, right? So looking at our picture, you can see we have 3 racks, and each rack can have a separate power source going to it and a separate network switch. And this is why these are fault domain 0, 1, and 2. So we have 3 fault domains, and each group of virtual machines is in a different fault domain. Then also in availability sets, we mentioned update domains. Update domains are used to indicate groups for virtual machines that can be rebooted at the same time. Yes. So in our scenario over here, this one's an update 0 set 1. So this one will get rebooted. But during those reboots, 1 and 2 would not. Then when it's update domain 1's turn to get rebooted, this one will reboot, but these 2 would not. So that's a very brief definition of availability sets. We'll talk more about those as the labs get bigger in size. Not bigger in size, in number, right? And here's another example of an availability set. It's kind of a different picture. Here we have a web farm in one availability set with 2 fault domains and 2 update domains. So you can see that IS1 and IS2, this is the classic way you would do it. If you have a web farm, obviously you wouldn't put them all in the same fault domain, because then if you lost power here, you have no front end. So this is perfect. This is picture perfect. And let's go on to the next slide. And it's just showing at least one virtual machine is available, and it meets the 99.95 Azure SLA with an availability set. If you only have a single instance VM, SLA is only 99 points. So you only get 1.9, and here you get a little more availability. To get even more, you need an availability zone, and we'll talk more about that later. Can't learn everything at once. All right, test your knowledge. Now, we didn't cover this. We covered this in a way, but I didn't directly say this. So you got to take some of your knowledge that we learned and apply it one step forward. So here we go. A fault domain protects you from software/OS issues. True or false? I like this question. I'll give you guys a little bit of time to think about it. All right, I think that was enough time. And of course, false. Fault domains protect you from hardware failures, network outages, or power failures, not OS, not software-related failures. Hope everybody sees why. All right, that's enough boring slides, but you know, slides serve a purpose. It's hard to do any kind of lab any type of background at all. So I'll boot up the lab and we'll be back.